Thank you, everyone. Thanks for joining me here today. I was a little nervous this morning for this talk, and then I realized there weren't any taxis in Hamburg, so I got very, very nervous. I thought I couldn't make it. So let's you can download this presentation because it's full of links and things you can maybe want to check out later. This presentation is going to, it's a suggested itinerary to start with observability. It's also focused for those that have already started with observability and they are not sure where they are, or where should they be, or what are the next steps. And also, I'm sure you did already, but don't miss yesterday's presentation by Dotan Horowitz about the data analytics approach to observability. It was super great. It was I enjoyed a lot. So what's in the agenda today? So we are gonna introduce a little bit what's observability. This is a very introductory presentation. We are going to see my suggested itinerary. And this is a very agnostic, I wanted this presentation to be very, very agnostic. So we are not talking about tools till the end of the presentation, because maybe you are using a different tool that I'm presenting, but that's okay. If that tool works for you, that's super great. But you know, there are a few standards that we can't avoid telling. A few applications super popular that I'll be introducing later. So basically, what's observability? Observability is like if you take a lenses with you and with X-ray or something, and you want to know what's inside your system, your platform, your application, whatever you have. And this is based on external outputs, right? You use different tools, you use different signals to get this information from. So basically, it's what you use in order to know what's happening inside your application. This is crucial. And this is obviously what everyone always talks about: logs, metrics, and tracing. This is like the basis. We need to start here, and then we can go forward. Okay, this is very basic, I know. Logs tells us what happened and when happened. Metrics tell us how bad was it, like how is the damage, and traces tell us where did it happen, because maybe we have a distributed system and full of nodes and different instances and hosts, and with the traces we can know exactly where did it happen. So let's start with a cloud-native itinerary. The first stage of every engineer that starts in observability is a very particular dashboard. This dashboard is like a standard dashboard, and I think everyone here have worked with this dashboard a few times. It's an error 500, like HTTP error. This is like the entry point at the first stages of an incident. This is like the entry point. The thing is, that sometimes in these states we don't have any observability. We don't have any tools, any particular tools for measuring what's happening inside our platform. So maybe we don't get this until it's too late. Maybe the customer calls us like super, super unfriendly, like my application isn't working. Or maybe, I don't know, your boss, like how did it happen? So right now, how's the team? I'm going to focus on the development team, but I'm also going to talk about different departments that we can coordinate. I'm speaking from the development team because I'm a software engineer, so that's where I'm at, where I am. So right now in the team, in that stage, it's just developers, people that write code, and then they coordinate with sysadmins, platform engineers, whoever, to deploy that code in production, right? So let's see an example. This is an example. Someone calls me. The application is down. How long has it been down? 1 minute, 1 hour, 2 days, maybe during the weekend? That's not good news, because you can't even tell the customer how bad is it. Then it happens, somebody calls somebody, and then somebody sends an Slack, an email, or whatever to the developer team. And the developer team starts working on it. If the application is completely down, then they just restart the application, right? And everything works again, right? We are happy? No, we are not, because we don't know why it happened. And we don't know when will it happen again. Because if it happened once, we know that it will probably happen again. If it's a software bug, this is better news, because we know what happened, but we needed to fix it ASAP to deploy a hotfix in no time, because the app is, as I said, down. So basically, this is like the summary of this. The main concern about the states, and the reason why we need to move forward as soon as possible, is that we don't have the ability to detect that something is wrong. So we are not sure. What are the best practices? Well, the top one best practice for this is to move forward to the next stage. But I understand sometimes it isn't as easy. So please have backups, backup strategy to recover everything. Have obviously testing environments very similar to the production ones, same infrastructure and everything, to test everything, to stress test the application, etc. And also improve testing, not only unit testing, integration testing, but also end-to-end testing, because at the end of the day, that's what matters for the final customer. So the next one is we added in the next phase we added a slightly change, but in my opinion it's a very big change. The receptionist phase, we have alerts, and alerts just based on availability. So something in our platform is going to tell us if our application is down. And now we can organize the team into roles. So there are developers, people that are following the product prioritization to add features to the product, to develop everything. But we can also have site reliability engineers in the team. These people will be in charge of starting the monitoring solution, the alerts and everything. And also, they will be receiving those alerts, and they will be dispatching and handling who should be fix this. Maybe it's a software bug, maybe it's an infrastructure issue. So this is the same scenario that before, but with this change. So the dev team receives directly an alert, because the SREs are in the dev team, obviously. So the dev team receives an alert. The application crashed 20 minutes ago. So we know the application has been down for 1 minute. We now have valuable information that it's just 1 minute. Then developer starts in no time working the solution. So maybe they need to, if the application is down, they restart the application. But if it's not the first time that this happened, someone in the SRE team might investigate a little bit and have installed some sort of exporter or software to get some node, some host metrics, right? So now we can have this alert. This alert tells if the memory free is less than 5%, trigger an alert. So now we can detect that this is going to go down in no time, but we have time to scale up the memory of our application. So now this won't happen. We'll talk about this a little later, but this is a PromQL alert, but this can be done with different solutions. So in the in this strategy, we are using what's called the black box approach. We're just focusing on availability mainly. And we're going to start organizing in on-call rotations. So if something's happen during the weekend, somebody will take care of it. Also, we are going to focus on availability, as I said. And what are the best practices? We need to start our monitoring journey here in this stage. We are going to start installing things to get alerts. And then also we are going to start adding some logs to our code. So we are going to listen what the SREs are telling us, like you should log this or that, because I can use that log to trigger an alert if something's happened. Also, we are going to start reading about the golden signals. What are the golden signals? Everyone in this room, I think, how many of you know what are the golden signals? A lot of people, right? The golden signals are a framework where you start when you want to know what's important in your platform. So when you have nothing, there is a very bad practice. Like I start creating dashboards, and every metric I know, every metric I understand, I put it in a dashboard, even if it's not important. So if I start adding metrics without thinking, a part of having dashboards that doesn't help me when something's wrong, I can also end up with some kind of cardinality explosion. Like we are going to have a lot of metrics, a lot of time series in our metric server. So this is not a good idea. So this framework tells us focus on errors in saturation, in traffic, and latency, because they are the four most important issues that we need to worry. And from there, we can go forward. But try to fit every query, every metric you add in your panels, in your dashboards, try to fit them in this framework. There's in that QR, there's an article that explains it further, and also in a slide in the end of the presentation, there's a list of links. So next, we are in the gardener phase. So we want to start to get the information before something's happened. We love the idea of knowing that the application was going to have an out-of-memory error in no time, like it was 5% or 10% of memory left. And now we want more, right? So in this phase, we start to have a lot of value information because we start monitoring our resources. We know exactly CPU we are using, the memory we are using, how's the traffic, how's the network. The latency, maybe we know that something's wrong with the database because there's a lot of latency when I try to write something in the database. So we start a new collaboration, a new conversation with other roles like cloud or solutions architects or platform engineers. Because until now, we were just requesting things to them. I need this, I need this. But they didn't have any context. We didn't have any information to give them. And now we know what happens. So we can tell them, we need this because take a look at this. We got this alert. Or we are usually getting out of memory, and we take a look at the code, and we didn't find any memory leak. So maybe we need more memory allocated. So they will see, OK, I don't see why can't we scale up your application. So this is an example. The SRE receives an alert. This is like an example of a happy scenario that we can have. The SRE team receives an alert, and we know that one host has been using less than 50% of the allocated memory for the last 2 months or so. So memory is super, super expensive, and this is just one host. Imagine if we had 40K hosts, right? So we need to save some money, and it's as easy as add this query right here. This is just a PromQL query, but we could do with any query we know right now. This is my I like Prometheus, so that's how I make my queries. But So now we can right-size the memory, and we can perform a stress test to test that everything, that the query was right, and then we've saved a lot of money, and our bosses are super happy. Also, another example, we get this error, this alert, like the cache is down. This is a very common error, right? This is not just an error. The application is working. Now, nothing happens, right? The customers are buying, are using the cart and everything, but the cache is down. So soon, the database will be down too. So this is a very interesting alert that we could have, because right now, we can go to see what's the status of our cache and fix it. Maybe it's a software bug. Okay, fix the software bug. We can deploy it, and nobody will notice that this was about to end, right? Also, in the log message, we can add a lot of useful information. Not just the log message, but we could add the exact line of the code that triggered this error. We can add some request or transaction information, like customer ID, date, or even we could add even the whole payload. So in this strategy, in this phase, we are starting to be in the game, right? We are starting to solve issues before they happen. So we can focus on capacity planning. We can even know, with this information, we can know how to do dynamic sizing of resources. In Kubernetes, for example, we can use HPA, VPA with this information. And also, if you like the logs example, you can also start to have a centralized log system, because maybe you have different applications, but having a centralized logging platform will help you a lot if you don't know exactly where things are happening. You just go to one UI and everything's there. Then there's the engineer phase. So now we want to have, like, here in the gardener phase, we had information before something bad happened. And now we want to improve the quality of the information that we are getting. Because until now, we are getting resources, right? Metrics and things like that, memory, latency, third-party exporters, for example, are getting us information. For example, if you're using Nginx and you're using the Nginx exporter, that you know the memory, etc. But you don't know exactly what's happening in your application. So now you want to have metrics about your application. For this, we need to instrument it, and there are a lot of ways of instrumenting the application. There's this, if you want metrics, you can use the Prometheus SDK or the Open Telemetry SDK. And this involves that the SREs need to develop some code. So we are back to how we started. In the team, we just now have developers, because we got to a point where observability is part of our application. So this is not an external thing we do to help us be happier, right? Observability now is part of the application, is at the same level of importance as the cart, as the front end, the whatever, some processes in the back end. It's as important as that. So now the SREs are developers as well, because they are instrumenting the application at different levels. They are adding logs, they are adding traces, they are adding metrics from the applications. So this is obviously the way I want to see it, but every team, every company has different organizing or organizing styles, but just I wanted to add the meme. So in the engineer role, roles, apart from being developers, we keep collaborating with the architects, obviously. But we had a new collaboration, collaboration line. We had a new conversation with the product managers and designers, because now observability is part of our product. So the product managers need to be part of that as well. They need to prioritize some kind of tasks that at the first time they can think, no, this is not for the product. This is for your nerd stuff. No. This is very important. We need to have this. We need to instrument this metric because we don't know how this will perform. So we need that kind of information. So we need to add the product managers to our site, and also designers. Designers are now have very valuable information about how people using the app I designed. So maybe since I changed this button from here to here, we are having in the traces I can see that that they don't go to the checkout page so fluently as before. So maybe I should change back the button. So this information helps the designers too, not only developers or IT nerds. This is an example. Maybe custom metric. We receive an alert from a custom metric. We learn that the order process, the order management process that we have in our e-commerce, that happens every time someone buys something, it's 20% slower. And then we go to the traces, and we learn that this only happens in one particular region. Maybe our store is in one country, and in that country is bank holiday or something, and they're buying a lot. So now we can do some capacity planning for that specific region, because we correlated what we got from the metrics with the traces we added. And this is like a summary. Basically, in this phase, we are instrumenting our application, and we are having also in the same conversation we are having the product managers and the designers. Now, the strategies phase. This is like the latest phase, and this is the phase like that the managers love the most, because in this phase we are saving money. In this phase, you can see in this dashboard that we could have some potential savings if we did some capacity planning to our clusters. So now we are going to help the product from the top of the chain, right? We are going to do the same we were doing at the same performance with the same quality, but cheaper, basically. So we are going to focus on FinOps and cost optimization, and also this will help the product team to prioritize better and to have business metrics. What tools can we use here? But things like OpenCost or Carpenter, things like will calculate a better configuration for our requests and resources, for requests and limits, for example, in Kubernetes. So now we have developers, we keep collaborating with the architects, we keep collaborating with products, and we add a new collaboration line with the legal department. Really? Yes, because the legal department is writing the contracts, the SLA contracts. And what if they are saying in their contracts, we are up and running 92% of the time? And you go there and you tell it, no, we are up and running 97% of the time. So there's a new way they can learn how they can improve their contracts and how they can be more accurate in the things they tell to the customers. So this is another thing to have in mind. So this is a summary of everything we had. We talk here. We go from having no information at all for having information when it's too late. Now we have information a little bit before that it happened, and now we have information about our application, business valuable information, and then we have FinOps information that helps our team to make things cheaper, with a few examples. And now we are going to talk about the tools now. So where do I start? I told that this was going to be a very agnostic talk. But there are a few open source projects that you might want to take a look at. You can use Fluentd, which is a log aggregator. You can use it for creating what I talk about, the centralized log UI. You can use OpenSearch for storing all these logs. There's a you can follow. There's a guide for using Fluentd with OpenSearch. Fluentd also, I love Fluentd. It also, for example, it helps you to improve or to create metrics based on logs. For example, maybe you can't instrument an application because it's an application you are using, but you are not developing that application. But that application has configurable logs, so you can use these logs with some regular expression magic to create a custom exporter for that application, for Prometheus, for example. So this is great. Prometheus, obviously, this is the standard for the cloud-native application. So if you want metrics, you probably are using Prometheus right now. Basically, how it works: application expose the metrics. Maybe they expose it via exporter, so you need to add an exporter to the application, like in these examples. But other applications expose metrics in Open Metrics format or Prometheus format natively. Yes, but adding some configuration during the installation process. Then Prometheus go to get these metrics and stores them. And if you want to have a long-term storage solution, you can configure it. Sorry, that's. Oh, you can configure LTS open source solution like Thanos or Cortex, or you can go to the market to buy some commercial solution. For example, CSD has an LTS Prometheus server that you can take your metrics there, and you can forget about configuring anything else. And now traces. We are going to talk a little bit about OpenTelemetry. Again, check the presentation, yesterday's presentation about the data analytics approach to observability, because he goes more on detail on the OpenTelemetry, how OpenTelemetry works. But basically, OpenTelemetry has this SDK for a lot of languages, like a bunch of languages. Very easy to use SDK. So you can instrument your application, and then you can use Jaeger to store these traces and also to consume them in a very nice UI, like this one you're seeing right in the slide. So this way you can correlate the metrics you see in one side with these traces. So these are the references I talked about. There are in the presentation. The getting started with PromQL is an article talking about getting started with the Prometheus query language, obviously, the code and signals that I introduced. There's a capacity planning blog post and a talk a colleague and I gave in KubeCon last year about how to do capacity planning with Prometheus in Kubernetes. How to use Fluentd to improve the Nginx exporter. The Nginx exporter only exports 4 or 5 metrics by default, and you could improve it a little bit using Fluentd and the Nginx logs. And also how to get metrics from logs with Prometheus, Grok, and Fluentd. This is another article about this. And that's all. Don't miss the presentation by Dotan Horowitz yesterday, because if you think this is useful, that presentation will go further on the telemetry stuff, on how to configure, not how to configure, but how OpenTelemetry works and how can OpenTelemetry helps you have these traces. And also, he gave a very, very interesting, very awesome point to how to consume all these 3 pillars of observability. So don't miss it. It was super great. And now, thanks everyone. You can download the presentation from this QR code. And
cool. Thank you. Thanks.